Hi everyone, we're going to look at how to take a sequence and write an explicit formula here. Now we know these sequences are arithmetic sequences because they have a constant rate of change that's either adding or subtracting. So for this first sequence here, it starts at -11, then it goes to -3, 5, 13, etc. And there's a constant addition here of 8. Every time here we're adding 8 onto the previous term to get to the next term. So that's going to be our rate of change or our slope for this arithmetic sequence. Whenever you think arithmetic, always think linear. It's a lot easier to think linear since we're so used to linear relationships. So for this one, it'll be good to kind of make a little table out of this. So this is the first term, the second, the third, the fourth, the fifth, the sixth. Now we don't typically start by counting the first one as the 0th term unless the problem tells you that it is. We have to kind of assume this is the first one at -11 because there's no reason to say it's the 0th term. You don't count things as saying that one is the 0 one, that one is the first one. No, we count them 1, 2, 3, 4. So this would be the n and this would be a of n. Now we got a nice little table based on that sequence. So from here we can then just write our formula. Again, we can just think linear, slope, and y-intercept. So if you were to work backwards here to 0, what would happen before the -11? Well, you got to think, well, something plus 8 would be -11. So the 0 term would actually be 8 less than -11, which would be -19. So if it were 0, we would have -19. That would be the 0th term if there were one. And we're going to need that for the y-intercept. Because for our linear relationships, we always have y equals mx plus b. Well, our m is just the slope, which is 8. And then our b is the y-intercept, which is -19. So one equation for this would just be y equals 8x minus 19. That would be one way to write this. If you want to use a of n's and n's, same idea. A of n equals 8 times n minus 19. Now, the formula on the reference sheet looks like this. A of n equals a1 plus n minus 1 times d. We could use this too. So this would be a of n equals the first term, -11, plus n minus 1 times the d, which is the common difference, 8. This is equivalent to what we already have down here. Let's kind of prove why that is. So a of n would be -11. Multiply this 8 in, it'd be plus 8n minus 8, which would be the exact same thing, -19 plus 8n, which we know we can rearrange that and get the other one right there. So another example here would be the next one, 26, 36, 46, etc. That one's pretty easy to see what we're changing by. We're adding 10 every time. So this is the first term, the second, the third, etc. So the 0th term would be 10 less than 26, which would be 16. So for our formula, it would be a of n equals the slope, 10, times n, plus the y-intercept, 16. And it really is that easy. You don't have to go any more complicated than that. As long as you find the y-intercept there and the slope, you're basically done because that's what an arithmetic sequence is, a linear relationship that just doesn't have any decimals for inputs. So for the next one here, a little bit different. So we've got -27, -34, etc., etc. This is actually decreasing by 7. Only a slight difference here. So this is the first term, second, third, fourth, fifth, sixth. So the 0th term would be something minus 7 is -27, so that would be -20 would be the 0th term. So a of n would be the slope, -7 times n minus 20, or plus -20. That would give us our relationship, again, using our slope and our y-intercept, which would be the 0th term. And that's how we write an explicit sequence formula for an arithmetic sequence that we're given.